morning, students. So today in this session we are going to talk about ions. In the last classes we did talk about molecules and the atoms, and I hope every one of you have some amount of information about the molecules and atom. So when we talk about this particular ions here, this particular name, this particular concept should be very important to all the class 9 students, for you to understand, for you to have a better information about the other chapters of class 10 syllabus also, right? So before we talk about ions, okay, I think it's important for us to know a little bit about atom. So we have some information about atom now, but we didn't talk about what atom is actually made up of, right? We did talk about that atom is the smallest indivisible particles, but normally in the case of atom they are made up of 3 subatomic particles. Atoms, they are made up of 3 subatomic particles. What is that? That is proton, neutron and electron. This is it: proton, neutron, electron. So you can somehow say that with the help of proton, neutron and electron, atom is being made, right? So I will write the structure here. Let's say this is the proton and this is a neutron. This is positive and this is electron here. This is negative by nature, and proton is normally positive and it doesn't carry any charge. This is negative here, okay? So I guess every one of you must be having this information. That is proton, which is positive by nature, and neutron, which is 0, that is no charge, and electron, they are negatively charged, and they are present in the form of something like this here. Electron, they always used to revolve around the proton and neutron, which are present at the center, right? So now talking about the ions, why is it important for us to study ions? Why ions are forming? That is important for us to know, right? Okay, so now the important thing you need to understand is that this atom, when they try to form connection with another atom, is that clear? For example, I as a human being, I also share some sort of connection with other human beings, which is why I can say I have some friends, I have some relatives, I have some family members, right? In the similar way, this atom make connection with other atoms. How do they make connection? They make connection through 3 different things here. That's number 1 is by sharing, and number 2 is by losing, and number 3 is by gaining. Okay, so we know that atom make connection with other atom by gaining, losing and sharing what they are going to gain, what they are going to lose, what they are going to share. So here, atom, since they are made up of 3 subatomic particles, proton, neutron and electron, you can somehow conclude here that it will not be possible for atom to lose proton and neutron. Atom, they are never going to lose proton and neutron, because the moment atom is going to lose proton and neutron, the whole identity of the atom is going to change forever. Understand? So what they are going to lose, in that case, electron here, this electron. So this atom, in order to make connection with other atom, what they do is that they either gain electron, or they either lose electron, or either they share electron. Is that clear? So whenever there is a gaining or losing of electron, there is a formation of ion. There is a formation of ions. Is that clear? Now you are still not able to understand what is ion, because I didn't tell you the definition of ion till now. What I said was why ions are forming. Because this atom, they has to make connection with another atom. When they make connection, they can make it through the 3 different steps here. That is by gaining electron, by losing electron, by sharing electron. But whenever there is a gaining and losing of electron, we can somehow say there is a formation of ion. Now let us try to understand the definition of ion. What is ion? Ion is charged species here. Ion is charged species. Charged species. Understand? That means you can somehow say there are some atoms which are going to come with certain kind of charge. And normally we know that there are two kind of charge here. Either that could be positive or it could be negative. So there are some atoms which are going to come with positive charge, and there are some atoms which are going to come with negative charge also. And these kind of like charge atom is what we used to refer as ions. Understand? So we will try to study one, get one example of ions here. Okay, so we are going to take the example of sodium. Okay, sodium. Now sodium is atomic number 11. That means sodium is an atom, is made up of proton and neutron and electron. Okay. Now sodium has how many proton? 11 proton. And how many neutron? 12. And how many electron? 11 electron. Okay. Is that clear? So now this I'm going to write in the form of table here. Okay. And I'm going to write the configuration. Now this is here. Let us say at the center there is a presence of proton and neutron, which I'm going to write in the form of plus here. Now, how many electrons is present? There are 11 electrons. 1, 2, 11. Okay, sodium. Is that clear? Now, I'm going to write here. Let us, for the time being, let us try to exclude this. We are not going to consider this now. We are not going to take this. But instead, we are going to take proton and electron here. Okay? So I'm going to write proton and electron. Okay? This is P positive here. Okay? How many proton is present? 11. How many electron is present? 11. Okay? Is that clear? Now we got this here. Now what we need to do is that there is a particular kind of concept called electronic configuration, which you are going to study in the next chapter, that is structure of atom. But it is important for you to have a little information about the electronic configuration. So what is electronic configuration here? The first thing is, this is what we call a shell. In a shell, first shell, an atom can accommodate, that means an atom can make space for only like 2 electrons here, 2 electrons in a first shell. In a second shell, atom can accommodate 8 electrons. Now, in the third shell, they can also accommodate 8 electrons here. Now, this concept is going to change when you go for class 11 and 12. Okay, so let's suppose imagine, okay, if there is an element which has only 1 electron here, that is 1 electron here. Now there is a space for 2 electrons, but there is a presence of only 1 electron here. So that means he can also adjust. He can also take 1 electron inside. There is a space. Understand? In a similar way, let's say this is 2 electron here, and there is an 8 electron here, and there is 1 more electron over here. Now that is in the case of sodium here. Now in the first shell, sodium gave the space for 2 electrons, which is over here. And in the second shell, sodium also gave space for 8 electrons here. That's 1, 2, 3, 4, 5, 6, 7, 8. That means strongly stable. Now in the third shell here, there is a space for 8 electrons, but sodium has only 1 electron here. Now that is something like an unstable state. So what sodium will try to do? It is the nature of the element that they are always going to go for stable state. That means he will always try to lose this electron. Is that clear? Okay, here. This sodium, he will always try to make himself stable. This sodium. As for now, as you can see, that sodium is not stable because there is 1 electron outside here. But sodium will always try to make himself stable. Now, how he can make himself stable? He can make himself stable by losing this electron. If he loses this electron, that means in the first shell there is a space for 2, in the second shell there is a space for 8 electrons, and over here there is no electron here. That means he loses 1 electron here. That is minus electron here. Is that clear? Now we are going to consider this now. how many proton at the center? Proton is going to be same, that is always 11. Understand? Now how many electron here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. Okay. Is that clear? Now there is a change in the number. Can you see that? Now sodium is Na. Which one is more in number? Proton and electron. Proton is more in number. By how much? By 10 and 11. By how much? 1. That's why we are going to write Na plus 1. Is that clear? So now this is 11 and this is 10. There is a difference of 1. And this one is more in positive side here. So I'm going to write positive 1 here. Is that clear? Now you must be thinking, where is this electron? Right? Where, for example, whenever the sodium loses an electron, this electron should go somewhere else, right? So we will discuss about the next one here. Let us talk about chlorine here. Chlorine. Okay? Atomic number 17. So I'm going to write the configuration here. 1, 2. Okay, can you see this now? Okay, now if you have a proper look on this particular thing over here, what you can observe is that chlorine has 17 electrons here. I'm going to count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And 11, 12, 13, 14, 15, 16, 17 here. So we can somehow say again he has proton of how many? 17 and electron of 17 here, which we are also going to write here in this format here again, like we had done before. Okay, is that clear? Now this sodium loses 1 electron. This electron is over here. Understand? Now in this case here, we knew that in the first shell there is a space for 2 electrons. And in the second shell there is a space for 8 electron, and the third shell there is a space for another 8 electron. But if we count here, that is 1, 2, 3, 4, 5, 6, 7. That means 1 is still missing. So what chlorine they used to do is that they used to take this 1 electron from here and they used to insert over here, which I'm going to insert over here. Is that clear? Now this electron jumps into this space here. Now this becomes stable. As I said before, all the elements, they always try to become themselves stable. Always try to get themselves into the stable state. Is that clear? Now this electron goes into that one here. Now the moment this electron joins this particular shell, 1, 2, 3, 4, 5, 6, 7, 8, it becomes very stable here. Understand? So our new thing here, now there is this, how many proton is that? 17. How many electron? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 here. 18. Okay, so now you have a look on this one here. Now there is a change in number. Is that clear? So now over here, this is again I'm going to write chlorine. But 17 and 18, which one is more in number? 18 is more in number. By how much? 17 and 18, difference 1. And this one is on negative side, which is why I'm going to write minus 1 here. Now this is positive 1. Okay, so now do you see charge over here? Charge, charge. Now these kind of a charged atom is referred to as ions here. Is that clear? Now whenever there is an atom with a charge of +1, that is a plus charge, whenever there is a positive charge, we used to call this as cation. Okay? So whenever there is an atom which is having a negative charge, we used to call this as anion here. So these are the two types of ions, that is cation and anion. Is that clear? So I shall see you in the next class with another concept of valency. Hello everyone. So in the last session we talked about the ions with the two types of ion being cation and anion. So now we are going to move forward with valency here. Okay. So now when we think about valency, I think it's important for you to understand two things here. There are some elements in the periodic table which are very reactive. That means they are always going to make reaction with other elements also. And there are also some other elements which are not reactive at all, right? For example, if you take an example of helium, neon, argon, all the noble gases, they do not react at all. Whereas there are some elements like hydrogen and chlorine, sodium, they are very reactive by nature. So normally in our life also, if there are some people who used to have a huge connection with the people, and there are some students who are well reserved and they never used to talk around, they never used to react around with other peoples. So we used to ask them why there is so much of difference there. Is that clear? So let us consider this point here. In the case of helium, neon and argon here, they are not reactive at all. They are not reactive. Not reactive. But there are, in the case of like hydrogen and let's say chlorine and sodium, they are very reactive there. Understand? So why there is a huge difference? Why there is a huge difference? So if we wanted to know the difference, why they are reactive and why they are not reactive, it is important for us to study the valency here. Understand? So normally, what is valency? We used to define valency as combining capacity of an atom. Combining capacity of an atom. Understand? How they used to combine? They have two options, either by gaining electron or by losing electron. Losing electron or gaining electron. Is that clear? So this is what we used to refer as valency here. Now let us take some example here. For example, in the case of hydrogen here, hydrogen. Now we say hydrogen is very reactive, right? So hydrogen is atomic number 1, and if you write the electronic configuration, as we have discussed before, in the case of electronic configuration, in the first shell there is a space for 2 electrons, but we only have 1 electron over here, so we are always going to write something like this here, electron. Now since there is a space for 2, there is a space for 2 electrons in the first shell, there is a scope for hydrogen to interact with other elements to get one more electron inside. Is that clear? So which is why hydrogen has a valency of 1. Is that clear? So this hydrogen, in order to become stable, as we always say that all the elements, they always wanted to become stable. So this hydrogen, in order to become stable, what they used to do is that they will try to bring one more electron. Is that clear? To make this 2 here. Is that clear? So how many electrons they are trying to bring? 1 electron. That is why our valency is 1. Now in the case of helium here, helium. Let us take an example of helium. In the first shell there is a space for 2 electrons, and helium has 2 electrons, and 2 electrons is completely filled. Now helium is in a state that I am not concerned about what other things about me. I have my 2 electrons in my own shell. So that's it. Now I don't want to interact with other electrons, other atoms also. So which is why their valency is always 0. Is that clear? They are not reactive. I hope you have understood this part here. Now let us talk about the next one also. Let's say, I'll take the example of magnesium here. Is atomic number 2 bulk. If we write the configuration, magnesium, in the first shell there is a space for 2 electrons. That is 2 electron is present in magnesium. 1, 2, 3, 4, 5, 6, 7, 8. Here. In the second shell there is a space for 8 electrons here. 1, 2, 3, 4, 5, 6, 7, 8. And inside 2, 9, 10. Now how many are left? 2. So I'm going to write 2 outside here. Okay? So now in the outermost shell also there is a space for 8 electrons. But over here, how much is that? 2 electrons. So now this magnesium is in a state that either this magnesium has to add 6 electrons, or either this magnesium has to lose 2 electrons. Now which one you are going to choose? If you are trying to bring 6 electrons inside, this will take a lot of energy to do that. Is that clear? But if you are trying to lose 2 electrons, it is more easier in this case here. So that is why the valency of magnesium is always 2. Is that clear? Now let us take the example of boron here. Boron. Atomic number 5. Okay? So in the case of boron here, 1, 2, 3, 4 and 5 here. Now in the second shell, there is a space for 8 electrons. But how many electrons you can see here? 3. So now in order to become 8, there is a 2 possibility here. Either he can plus 5 electrons, or either he can remove these 3 electrons to make himself stable. If he remove this, this is going to become blank, this is 2, and this is again stable state. So which one you are going to choose? And you are definitely going to go for this, because this is more easier task for you. So that is why the valency of boron is 3. This is how we are going to write the valency. So valency is the combining capacity of an atom by gaining an electron or by losing an electron, is what we used to refer as valency. Understand? So now, if you are able to understand the valency, we can also we will be able to write the chemical formulas here. Okay. Okay, now we will try to write down some of the valency. Let's say valency. Okay. Let's say I'll start from lithium, beryllium, carbon, neon. Atomic 3. This is 4. I guess every one of you are quite familiar with periodic table here. 5, 6, 7, 8, 9, and this is 10. Okay. Now in this case here, in the first shell there is 2 electron, second shell 1. 2 plus 1 is 3. 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and 2, 7, and 2, 8. Okay? So now this the yellow shaded portion is the second shell. Understand? So now we knew that already that in the first shell there is a 2, and in the second shell there is a space for 8 electron here. Now if there is an 8 electron over here, this is 8 completely filled. That's why the valency is always we used to take as 0. Now over here this is 7. Now in order to become 8, how many electrons is needed? 1, we write. How many? 2. How many? 3. How many? 4. This is a different case here. This is common. As we were discussing, that valency normally is all about adding and gaining and losing of electron. But in this case, they share electron. Okay, let's just leave this for the time being. You will study about this more in class 10 in Carbonyl compound chapter. Okay. Now about this boron here, 3 electron, but there is a space for 8. So what you can do is that you can add 5. Understand? You can add 5. But this, to add 5 is a very difficult task, considering so much of energy, involvement of energy, right? So we don't take 5. But instead what we used to do is that boron there is a 3 electron, we remove this 3 electron. If we remove this 3 electron, we will reach a stage 1, 2, and this 3 electron is removed. Now this is stable here, because there is no electron here, totally stable. That is why the valency is 3 here in this case. In this case, instead of adding 6 electrons, we remove 2. Understand? Instead of adding 7 electrons, we remove 1, like this here, valency. Is that clear? So now by using this valency method, we can also write some chemical formulas also, right? Okay, let's go for it, chemical formulas. Okay, so number 1, let's go for hydrogen and chlorine, hydrogen chloride, hydrogen and chlorine. Hydrogen has a valency of 1. Understand? And chlorine has a valency of 1. How? Because chlorine is atomic number 17 configuration is 2, 8 and 7. Is that clear? Now in the third shell there is a space for 8 electron. But how many electron is present over here? 7. That means he has to add another 1 electron. So how many electron is needed over here? 1 electron. So that is why the valence is 1 here. Now this is what you are going to do. You are going to multiply cross in a cross way. So we are getting H1 Cl1. This we can cancel it and we can write HCl. Understand? So let's talk about sodium oxide here. Na4. Sodium is atomic number 11. That means 2, 8 and 1. Is that clear? Now in the third shell there is a space for 8 electron. But he has to add 7 to make it stable. So adding 7 electron is very difficult again. So what he does, this sodium, he removes 1 electron. So when he removes 1 electron, this becomes something like this here. 2 and 8. And this is totally blank. He removed that. And this is a stable state. Now how many electron he is removing in? That is 1. So that is why valency is 1. We have to consider that electron which is being removed or which is being gained. Is that clear? Depending upon which one we are going to prefer. Now in the case of oxygen here, atomic number is 8. We are going to write 2, 6. Understand? So how many electron? In the second shell there is a space for 8 electron. How many electron we are going to add? 2 electron. So that means 2. Now we are going to multiply cross in a cross way. Na 2 and oxygen is 1. Whether right or not doesn't make any difference. So this is the way by which we take out the chemical formulas. I will take one more example here. That is the case of sodium chloride, NaCl. Again, the valency of sodium is 1 and the valency of chlorine is 1. And if we multiply straight away, we get Na1 and Cl1. This we can cancel it. We will get NaCl. Is that clear? So by using this valency method, maybe you can try to find out, okay, the magnesium chloride, okay, try to see what kind of formula you are getting between magnesium and chlorine, aluminum and oxygen. Is that clear? This try to find it out. Is that clear? I hope this is not a difficult task if you understand the concept of valency. Is that clear? So valency in general means the combining capacity of an atom by gaining electron or by losing electron. Is that clear? So this is the concept of valency. By using valency method, we can find out the chemical formulas also. So this is it. Thank you very much, all of you.